Uh, Hello, guys. Uh, Welcome to our lesson on integration by parts. So, for this video, this is for both N5 and N6 because I've realized this is exactly the same content or same question in both levels. So, yeah, I'm not gonna do two separate videos. It's exactly the same thing. So if you're doing N5, just master it so that in N6 you already know what you already know how to do the question. Okay, let's get started. First, we have to know how to identify the by parts questions. Remember, when you write, they just give you a question and you have to know which methods to use to solve it. So you have to know if the question is going to need by parts or what. So yeah, in question, in Maths N5 it's usually question 4, in N6 it's usually question 6. So here I have N6 question papers, but yeah, it's the same thing, and the method of identifying the questions are exactly the same. So let's get started. Okay, before this I want us to go through the formula sheet first. So okay, let me just go back here. I want to see if in the formula sheet they tell you if this is by parts formula or they just give you the formula. I know in N5 you go to your formula sheet, the section where it's written integration. I think it's the first question in integration. In N6, this one here on my screen is N6. So in N6 it's the first one also, but they didn't write integration there because almost everything is integration here. So you see I have integral f of x g prime x dx equals to that thing. So in N5 you also have the same formula. In N5 it's also in this order. The first formula is this one, the second formula is this one, the third formula is this one. Just that in N5 they wrote integration at the top. Yeah, but it's the same thing. Okay, now let's go back here. Okay, someone is working here and it's making a lot of noise. I hope this microphone doesn't catch that. Okay, so it says if I have integral of two different form, f of x g prime of x dx, it says my answer will be f of x gx minus f prime of x gx dx. That's my answer. So you have to identify first, is my question, or does my question have two different formulas or equations? If that's the case, then one equation is f of x, another equation is g prime of x. So if I have f of x, I need to determine f prime of x. We know how to do that, right? From f of x to f prime of x, it's derivative. Then if the other part of the equation is g prime of x, now I must determine g of x. And we know going from derivative to the original equation is integration. We integrate this one from here to here, we differentiate, right? Yes. So now the tricky part, and I don't know if it's many things that make this mistake, but I've noticed with my students it can be a common mistake to identify which one is f of x and g of x. And it's not always that the first one that comes is your f prime of x. Now there's a formula to pick that. So how do you pick? You only need to know one. So we're calling it picking or choosing f of x. Picking or choosing. I don't like using the word choose because I don't know if it's double O or one O. So yeah, but I think I once read where it says one O, it's past tense, like chose. I hope I'm correct, but this is not English class, eh? Anyway. So when you choose, you are following this 4 steps. The one that comes first is your f of x. So the first one is always lin function. Then the second one is a normal function, your algebra function, which is x exponent n, like x squared, x cubed, x exponent minus 1, even x alone, even 3x is x exponent n. Then after this we have an exponential, which is a exponent x or e exponent x. Then the last one is trig functions. So if I have 2 equations, let's say I have determine integral of 3x and sine x dx. So I can see my x exponent n here comes first before trig. Trig is always the last one. So every time you see a trig equation, just know trig will always be a g prime because it's the last one. Then this one will be f of x. You see, this was straightforward. Let's do number 2. Let's say now I have e exponent 2x and ln 3x. Do you see, ln is always the first one. So the one that comes first, it's your f of x. This one is my g prime. See, let's do the last one. Okay, doesn't matter. You can have x cubed and 3 exponent x. I hope you can see. This is x exponent n. This is a exponent x. So this comes before a exponent x. Do you see? So guys, if you check all these equations, they are different. I have x exponent n times trig. I have exponential function times a ln function. I have x exponent n times exponential function. You see? So you can't, for example, if I'm given x cubed times 3x. Do you see? Both these equations are x exponent n. So we know we can, that's not by parts. You can just simplify this into 3x exponent 4. Then do your normal integration, which is adding 1 to the exponent, dividing by answer. You see? So this was not by parts. So that arrow, I mean that cross, it doesn't mean it's wrong. I'm saying it's not by parts. So now I want, before we do questions, I want to clarify a few things quick. Guys, let's say I have this question and this question. Let's say this question is for example, let me say 3x and e exponent 2x dx. Let's say this equation is x and e exponent x squared dx. I think this can be a very common, I think, but though it's like this, I think when you do integration by parts, you'll still get the answer. But I think you should know when you practice and you get used to such questions. For example, I can see with question 2, if I say that whole exponent is u, then my du is 2x, which means I only need to put 2 here. If I put 2 there, I must put 1 over 2. So which means now I have e exponent du times du. Du is this and this. And I know how to integrate e exponent u. My answer is just e exponent u plus c. You see, if you did this by parts, you're going to go through a very long method. So you should check every time. If you have exponent, before you conclude that it's du, check if the exponent of your of your function, it's not this, and the derivative of that is not the same of what's multiplying there. For example, here the derivative of 2x is 2. I have 3x, so you can see now this is two different functions. It's x exponent n and e exponent x function. So this one will be f of x, g prime of x. That's important, guys. And I've seen these common mistakes in trigonometry. So let's say I have, so obviously if they give you a function of exponent, if they give you exponent with something completely different, you see, now you cannot think it this way. You can't think it as du, because we know the derivative of x squared is x, and we have sine, and the derivative of sine is cos, so you can't think it of that way. The only way is to do the other one, by parts. But I've seen, especially in N5, they like tricking you. They can say the derivative, they can say sine square root of sine x equals to, what is the derivative of this? It's half x exponent minus 1. They can just say times this, it's dx. See? So you might think the sine and the this is two different functions, so it's by parts, but it's not, because now if I'm going to say, remember in your formula sheet you have arc sine f of x times f prime of x dx, the integral equals to minus cos f of x plus c. So that's another reason we are saying sine 2x dx, it's negative cos 2x over 2 plus c. Okay, not negative, sorry, it's the integral of sine is positive. Oh yeah, it's negative. Yeah, but it's always important to check the formula sheet if you're not sure. So the reason we are dividing by 2 is because we first check here the derivative. If this is f of x, the derivative of that, but I don't like using f of x. If this is u, the derivative of u, it's 2 dx. You see, but I have 1 dx, so I'm going to put 2 and put 1 over 2 outside. So which means now I have 1 over 2 sine u du. The integral of sine, it's minus cos u over 2. The over 2 is this 1 over 2 plus c. Then now you substitute u, is 2x. So that's how this over 2 came from. So even here you're going to do the same thing. You're going to say if this is u, the derivative of that is minus half x exponent minus half dx. If you simplify that, I have minus 1 over 2 root x dx. Now you check, I have positive 1 over 1 here. So if I put minus 1 over 2 outside, I must put minus 2. Do you see? Then now this is sine u. This whole thing now it's du. I have minus 2. So my answer will be, since this is minus cos, it will be positive cos u plus c, which is positive cos square root of x plus c. You see, there I just felt like I'm teaching you substitution, and that's not what I wanted to. I just wanted to show you that before you conclude it's by parts, make sure that it's really by parts, especially if you have functions like exponent, you have functions like trigonometry also. Make sure. Okay, let's get started. Let's go through these questions quick. 4 different papers, we'll see because of time. Sorry for the screen, I'm moving fast. So if we check question 2, we can see 2 different functions. It's exponent and trig there. That's our by parts. How do I hide? I'm trying to hide this. Can I hide this thing? Okay, here's another one. If you see here, okay, here it looks like we don't have it, but we actually do have it. It's number 2. Because if you check all the formula sheets, there's no way you have integral of arc function. There's no way. So every time you have integral of arc function, you are going to take it as 1 times that arc function. So now this becomes your one function, this becomes the other function. But this time, since this is trig, it's not g prime of x, it's f of x. Because if we say this is g prime of x, how are we going to get g of x if we just said there's no integral for this? You see? So this is the only way where trig, it's not g prime of x, it's f of x. Yeah. Okay, let's move to another one. Okay, if you check here, number 3 looks like it's that we have ln this. We see these two looks the same, but they are not the same. We have ln of that times this, so it's 2 different functions. Another thing, when you get to N5, sometimes they tell you solve it using by parts, so it's better. They told you, but if they don't tell you, you must know how to pick it. Okay, let's check the last one. Question 2. I can see this looks like, let me see if it's not the same paper as this one. Yeah, do you see it looks like this one from the other paper, the first one we checked. This is e exponent minus 3x, this is positive 3x. Yeah, so we'll do only one, we won't do 2 of them. So it's this one. Okay, I want to just clarify something. So if I get a question like this, let's say 3x times ex, this one, it's easy. If I get ln x times x exponent 10, it's also easy. The only way, remember that order, it's ln x, it's x exponent n, it's ex, it's trig. So if you get this one with this 2, with one of these 2, you are going to, it means I'm going to integrate n times, which means if I have, for example, let's say I have x exponent 3 times e exponent x, it means I'm going to integrate 3 times, because the exponent is 3. If this was exponent 2, I'm going to integrate 2 times. If it's exponent 1, I'm going to integrate once. Why do I have to integrate 3 times? Because if I integrate first time, remember this is f of x. I have to get what from f of x? F prime of x. So if I differentiate f of x, I'll get x squared. So I'll have x squared and exponent again. If I integrate again, I have now x, which is the second time. If I integrate the last time, I have a constant. So you integrate until this is a constant. Even with trig, it's the same thing. If I have x exponent 4 sine x dx, you are going to do it 4 times. But they don't usually give you so many times. They can give you x squared, maybe x cubed maximum, but they don't make it so many times. You see? So we'll do one question where we have, if you check here, I said ln x exponent 10. You see, because ln it's at the top, it's different. But if x exponent n multiplies the ones at the bottom, this is when you're going to integrate n times. Yeah, so that's also important. Now the last one is if exponent multiplies the one at the bottom, which is trig, which means only trig. Let's say I have ex cos x. Every time you see exponent and a trig, only these two. Exponent doesn't mean ex only. I can also have 2x sine x. So as long as the x is part of the exponent, it's an exponential function. Every time you see this, from the beginning, just call this I. In some books, they don't call it I, they call it A. So it's up to you, A or I. And every time you see exponent and a trig, it means you're going to integrate only twice, maximum of twice. When I integrate the first time, this cos will change to sine. Then when I integrate again, that sine will change into cos. Then now I will have this same equation again. So that equation I will now call it I. You see, then I can solve for I. You'll see. Let's get started. We are running out of time. So I'll start with the easy one. Let's say I have 3x times ln x dx. Remember, ln comes first every time. So which means my f of x, it's ln. If ln is f of x, f prime of x, we know the derivative of ln is 1 over x. Then the other one is g prime of x. What is the integral of 3x? It's 3x squared over 2. You don't have to add plus c. You'll add plus c on the question you're doing. So now I'm solving for my integral. Guys, I don't know. I think we've went through this. Maybe we didn't, but let me just go back to the formula sheet again. Yeah, we did. No, there's no need. Remember, the formula says f of x. You'll be checking the formula. The answers to integration by parts is f of x times g of x. So f of x times g of x minus integral of f prime of x times g of x. Do you see? Now we can see the ln x 3x squared. I can just write it like this, or you can leave it like that. There's no need. Now this other bracket, let's first simplify. Do you see that 3 over 2 is a constant? I can take it out. Inside I'm left with what? X squared over x is x. You see, now we are done because we know the integral of x is x squared over 2. So I have 3x squared ln x over 2 minus 3. The integral of x is x squared over 2. That over 2 and this 2 becomes 4 plus c. You see, this one was straightforward. Plus c. Okay, now let's do ln and anything. I like this one because I think students, they think if I have something like this, it means I must integrate 10 times. It doesn't mean that. Only if you have this and a trigonometry or exponential. So let's do this. We know ln comes first. What is the derivative of ln 3x? It's 1 over x. Because I've been doing this, and if you practice, you get used to it. Why is it 1 over x? Because if we do chain rule, it will be 1 over 3x times the derivative of 3x, which is 3. So this will always cancel. And that's what I've noticed every time. So every time you have a number, they just know it will cancel out. So okay, then the g prime will be x exponent 7. Then the integral of that will be x exponent 8 over 8. Let me put this here so that it doesn't confuse anyone. So now what's the answer? The answer is f of x times g of x minus f prime of x times g of x. You see, it looks like we are done again. So also here I can start with this, but guys, remember, you can leave this exactly as it is. This term doesn't matter. Now let's simplify here. I'm taking 1 over 8 outside. X exponent 8 divided by x, I'm left with x exponent 7 dx. Now x exponent 8 ln 3x over 8 minus 1. Okay, x exponent 7, it will be x exponent 8 over 8. That over 8 and this over 8 becomes 64 plus c. Okay, and we are done. Okay, yeah. our video is now on like 25 minutes, so I think we should just do the last two. I don't like an hour videos, they are too long, so let's try to keep it up to 40 minutes. Okay, so now I want to do the one where you must integrate. Remember I said if you have this and exponent or trig, it means you're going to integrate 2 times. You see, if you have, x exponent and exponent or a trig, you must integrate 2 times. So we know x exponent n comes first. What is the derivative of that? It's 2x. G prime is, how do we integrate exponent? We know first step, it remains the same. Divide by 3 plus c, but you don't have to write plus c. Now what's the answer? The answer is f of x g of x minus f prime of x g of x. Now do you see this integral? I still have another integration by parts because I have 2x and exponent. I can't just integrate that. You see, it's another integration by parts. So now, before I integrate by parts, it's up to you. Before I do another integration, I like simplifying things so that I don't have to get confused. So I will take 2 over 3 outside. So now I have only x and e 3x dx. Now I can integrate by parts again. So this, okay, before, let's just say f of x here is x, f prime of x is 1. Do you see now I have a constant? That was the whole objective. Integrate until you get a constant. This one is still this. The g of x is still this. Now, what did I do? Now when you write the answer, don't forget this part here. It's still there. It's still part of the whole answer. Minus, don't forget the 2 over 3. Then put a bracket because this whole answer with f of x, integration by parts, it's only this integral part. So you must put the bracket so that 2 over 3 multiplies everything. So f of x times g of x minus f prime of x times g of x dx. You see, now I'm close to being done. X squared e3x over 3 minus, if I multiply by 2 over 3, I'll have 2e3x over 9. This minus and this minus, I'll have positive 2 over 3. Then the integral of e3x over 3 is e3x over 9 plus c. Then this 3 and this 9 will be 27. See, you are done, just like that. Okay, I think I missed something here. Here I have 2x. Remember, this is 2 over 3 times this one. It's 2x e exponent 3x over 9. Because another thing you should notice, this x keep on losing an exponent until it's a constant. It started as exponent 2, now exponent 1, now exponent 0. So even if you had x exponent 4, it will start as x exponent 4, 3, 2, 1, 0. You see? Okay, let's do the last one. This one I like it. They like this kind of question. I also like it because then students. Okay, I think this one, if I do with n, let me just use. Let me see time. Okay, we still have time. I'll do 2 questions. I'll start with, because I've noticed all the questions I did, I'm only using e exponent. I don't use a number. So let's say I have e exponent and sine x. Remember, every time you have an exponent and a trig, it means you're going to integrate only twice. And from the beginning, just call this I. In some question papers they call it A. So yeah, make sure it's up to you, I or A or C or just any alphabet as long as it's not X. So okay, if you notice, I said I'll do this question papers, but I didn't do any of this question. But it doesn't matter. This is the same thing. So it gives you a chance to go do these questions on the question papers. E minus 3x cos 3x. It gives you a chance. But the last one, I'll just do this one. But do others. Okay, let's continue. So we know trig, trig is the last one. It will be g prime. So f of x is 2x. What is the reason I don't like this is there's many numbers involved. What is the derivative of, and that's another reason they don't give you this. Okay, we know the derivative of this is this ln 2. Then what is the other one, g prime? Yeah, the reason they don't give you this is because of that ln 2. If I'm working with e, we never have the ln 2 because ln e is 1. Okay, the integral of sine, it's negative cos. Now, the answer now you put I because I'm solving for I, right? So I equals to f of x times g of x minus f prime of x g of x dx. Now let's solve. I can say minus 2x cos x. This minus and this minus will be positive. Ln 2 is a constant. I'll just take it outside. So now I'm left with cos 2 exponent x cos x. You see, now this part, let me see if I can use the red color. Now this part is another integration by parts. See, so now I have f of x again is 2x, f prime of x again is 2x ln 2, g prime of x is still sine x, g of x is negative, oh this time it's cos x, sorry, because we are here, then the gx will be positive sine x, you see. So now we integrate again. So my answer will be, I still have this first term plus, don't forget the ln 2 outside. So now what is the integral of this? It's f of x times g of x minus integral f prime of x g of x. You see, now don't forget guys, everything we've been doing, we've been solving I. So now I still have minus 2x cos x plus, now I can multiply inside the bracket with ln 2, so I'll have ln 2 times 2x sin x minus ln 2 squared. Why is it ln 2 squared? Because it's this ln 2 and I'm taking out ln 2 here. So it's ln 2 squared integral of 2x sine x dx. And this takes me to my point, the one I tried to tell you when I was explaining. We will always have this I again. You see, now this is what we are going to substitute as I. Now we are almost done. So I will have I equals to minus 2x cos x plus ln 2 2x sin x minus ln 2 squared I. So how do I solve I? Now I can add c because there's no more integral. How do I solve I? I take ln 2 squared I to the other side. So now I will have positive 1I plus ln 2 squared. Then I have I. So let me just put that in the calculator. So 1 plus ln 2 squared. So we'll have 1 plus bracket ln 2 squared is 1,48. Yeah, let's just say 1,48. So this is 1,48 I. Then this side I'm left with this plus C. Remember, I'm looking for I, so I have now to divide the whole thing by 1,48. 1,48. That's your final answer. You don't have to divide C by 1,48. C just means a constant. A constant can be any number. You see, that's your final answer. So now when I'm doing this question, I just noticed that's the reason they never give you a number exponent x, because of these decimals. Yeah, but if they do, that's the only way to do it. Okay, otherwise this is a video, so if you don't get anything, you just have to rewind and check step by step. Okay, let's do this one from this paper. I don't know what paper is this, but it's between 2020 to 2022 paper. Okay, guys, what happened to my, I hope I didn't stop for the recording. Hey, thought I've been talking alone. So this is minus 3, e exponent minus 3x cos 3x. This is the last one. We have determine y dx of e exponent minus 3x cos 3x dx. So you just name it I or A. So let me use A this time, but it's the same thing. So we know cos, we still have to do, but no, that one you have to do it alone. We still have, okay, let me just write f of x, it's this, f prime of x, it's minus 3 e minus 3x. G prime of x, it's cos. What is the integral of cos? It's positive sine 3x over 3. Now the answer for A is f of x times g of x minus integral f prime of x g of x. So before we integrate again, let's simplify that integral. So I have e minus 3x sine 3x over 3. This minus and this minus will give me positive. This 3 and this 3 will cancel, so I'll be left with e minus 3x sine 3x dx. You see, now this question here is the one we must integrate again to take us back to cos and name it A. See, now let's not forget. Okay, let me do this. This is e minus 3x. This is minus 3 e minus 3x. This one is sine 3x. The integral is negative cos 3x over 3. Now the answer, let me take it back to white color. Don't forget, this is still A equals to e minus 3x sine 3x over 3 plus the integral. Now the integral, I don't have to open bracket because it's plus, so which means nothing will be affected. So plus e minus 3x times, which is f of x times g of x, cos 3x over 3 minus integral of f prime of x times gx. Don't forget dx there. This is still A, so I have e minus 3x sine 3x over 3. Then that minus will make that whole thing minus. Then this minus and this minus will be positive. Then 3 and 3 will cancel. So I'll just have positive 3x cos 3x dx. So now tell me, do you see this is exactly a? This is that a from the beginning, the one they gave us here, the one we said it's a. See there. So that's what we are going to do now. We are going to say a equals to okay, but even if that's a, I think we missed something because it looks like a and a will cancel. If this is positive a and this a, they will cancel. They shouldn't cancel. Let's just quickly check. I'm sorry for this. This is a video. We shouldn't be making mistake like this. So f of x, g of x, it's fine. Minus f prime of x, g of x. Minus and minus, we said it's positive. The 3 and 3 cancelled. Yes, that's perfect. Positive, yes. Let's come here. F of x plus f of x, g of x minus. The minus is there. Then minus f prime of x, g of x. Yeah, this looks perfect. What could be there? What could be wrong? Because if this is positive a, you take it the other side, it will be minus a. Okay, let me just finish writing this. Because if we say this is a plus c, the a and a will cancel. If that was minus a, then we would get something completely different. Yeah, but let me just confirm. What paper is this? Yeah, you see, with these long questions, you can just make a small mistake somewhere. November 2020. That's a problem. You can always just make a small mistake. Yeah, but for now, because I'm alone, it's not easy to see a mistake. If I was in class, students can just say you made a mistake there. Now I'm alone and I'm just chasing time. But let's see. Yeah, that looks like it was 2. Okay, the first step, I'm checking the memo here. Sorry. The first step, we got e minus 3x sine 3x over 3 plus e minus 3x sine 3x. Yeah, that's what we integrated. Then we got minus 1 over 3 cos 3x minus. This one they got minus. Okay, but let's check. Oh, yeah. That's do you see the mistake? Remember, this minus and this minus will make positive, but positive inside, not positive outside. That's the mistake, because we have minus 3 minuses, so we'll have minus. That's the mistake we made there. And I'm sure someone watching a video already saw that. It's just that you can't correct me because this is minus, this minus 3 and positive, that will make positive. Then this will be minus. Yeah, you see, that wasted my time. Now you take a the other side. This a's, they never cancel, otherwise we will never get an answer. Yeah, but I'm sorry for that. You see, I couldn't say that because when you're doing a long question, you can't see where you went wrong. You have to go back, take time and check. But yeah, avoid mistakes. Okay, guys, so the final answer, we divide by 2, right? If I divide by 2, I have sine 3x over 3 . Okay, and I think, okay, here divide by over 6 also plus c. Yeah, looks like it. 1 over 6, 1 over. Okay, and also let me go back here. Did I do? Yeah, I don't know why I like mistake. Do you see this whole term from the beginning has been positive, positive. And I'll tell you why. How do I identify this? I hope you can see this term from the beginning was positive, positive, positive. I don't know why I made negative. But how do I identify that? You see, guys, your answer will be positive, negative, positive, depending on how many terms you have. If you had 4 terms, you'll have positive, minus, positive. Or if this was minus, the second term will be positive, then minus, positive, minus. And your trick, if it's sine, if it started with sine, it will be sine, cos, sine, cos. If it started with cos, it will be cos, sine, cos, sine. You see, the signs change from positive, minus, or vice versa. And also your tricks, this change between sine and cos, sine and cos. So yeah, that's how you should check your answer always, and check if you didn't make mistakes. Yeah, guys, I'll end it here. Don't forget to practice the one where you have arc function. I said every time you have arc function, take it as 1 times. Then you take this as f of x, you take this as g prime. If this is, oh no, I said this is the only time this is not f of x. The reason we are doing it like this is because we know this doesn't have an integral from the formula sheet, but it has a derivative, so we take it as this because we know it has a derivative, and we know the derivative of arc sine is 1 minus 2x all squared, which is 4x squared times 2. You see, then you take 1 as g prime, then this will be x. If you go substitute, your answer will be f of x times g of x minus integral f prime of x and this and g of x. Now your integral will have f prime of x and g of x, and this will be u substitution. You take this to the top. You see, just practice this. I'm not gonna show you that. Yeah, and I'll see you again when we do the next video. Thank you, guys. Let me cancel.